So let's do a third example. I'll call this example 3. I'm going to do this example by what some people would call a brute force method, because there's a much more elegant way to show this, but I want to give you all practice with these truth tables. So for this, let's show that any implications converse is logically equivalent to its inverse. Let me say that again so you can get that. Any implications converse is logically equivalent to its inverse. So let me give you the solution, and I'll tell you the little roadmap to get to the solution. The final statement for full credit will be exactly as it is here. You will say the tautology establishes that, and then you will say any or every implications converse is logically equivalent to its inverse. So we're going to show that we get a tautology. So let's have A, B, and let's write the converse of the implication, and that's B implies A. And if you don't remember that, you can go to the beginning and you'll see here is the definition of the converse, B implies A. And the definition of the inverse is not A implies not B. So let's put that in our truth table. Not A implies not B. And some people like to put parentheses here. So for clarity, I'll put these parentheses. And we want to see if these are logically equivalent. So to help get this complexity, I'm going to write the word converse over here, and I'm going to write the word inverse over here. So let's go through all the possible truth values. We have true, 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 false, false, true, and false, false. And let's copy down all the A's first, true, true, false, false. And let's copy down all the B's, which is true, false, true, false. And that's step 1, which we've done in black. To be consistent with the previous videos, I will do step 2 in pink. So step 1 is black, step 2 is pink. So now let's negate these truth values. False, false, true, true. And here we have false, true, false, true. And let's get this implication. We have true, false, anything is true. True, false is false. And false implies anything is true. I should have said the word implies. It's important to get that right side of your brain to kind of help out in a whole-brained way. So it's good in your mind if you actually say true implies true is true. False implies anything is true. True implies false is false. And false implies anything is true. So saying the word implies helps you really think about this. That's just a little tip that I want to give you guys. So now the next step I am going to do in sky blue. So step 3 we'll do in sky blue. So here we have false implies anything is true. False implies anything is true. True implies false is false, and true implies true is true.
I have a question. Are you using the A implies B truth table to get those answers?
Indeed I am. And that is a good thing. In my opinion, the logical language should be memorized. So if with one F, then, if with two Fs, then, and, or, and not. Those truth tables should be memorized in long-term memory.
So then the next step that you're going to do, if I'm not mistaken, is using B implies A answers with the not A implies not B answers.
That is correct, Joe Tech. Let's hear it for Joe Tech. So I'm going to use for step 4, the color I will use is green. So step 4, I'll do in green. So we want to see if, now this over here is if with two F's. This is if and only if. So I'm writing this if with two F's. I don't have room to write the word then, but this is if and only if. And if and only if is the same as logical equivalence. So that means these two truth values should be the same, which they are. And these two truth values should be the same, which they are. And these truth values should be the same, which they are. And these truth values should be the same, which they are. And so here we've demonstrated the existence of a tautology. So the final verbiage to get full credit on this question should be the tautology establishes that every implication's converse is logically equivalent to its inverse. So that's the brute force method of doing this. There's a more elegant way, because once you've established that an implication and its contrapositive is logically equivalent, you can see that the inverse is actually the contrapositive of the converse. So you could have done it in a more elegant way. If that went above your head, don't worry about it.
So what? So then you're changing this inverse portion to the other, because you said in the beginning what they meant.
Right, but that would be a separate video. So
right.
I don't know if we want our viewers to. That could some viewers will connect with that and be like, oh yeah, that would be such an easier way to do it. But part of the purpose of this is getting experience actually using truth tables. So the brute force method is actually a good thing to practice. So if you've liked these examples, give us a thumbs up and subscribe and send me your comments. Constructive criticism would be appreciated. No foul language, of course.
Exactly.